Hello friends, George here, welcome to the channel. Today I want to share something special with you. I managed to transfer this picture here from a Raspberry Pi, which you can see here, over the Userport to the Commodore Plus 4. It took me several weeks to get this done. Because I am so happy about this, I want to make this small video, explain what I've done in this period, because I'm not an expert in electronics. This took me a while to figure out how the Userport works and what protocol is needed to run this file transfer over the Raspberry Pi. Fascinating stuff. The best part is the Commodore Plus 4 has a Userport which supports the RS-232 protocol, which is the serial port, which we know from the old PCs. And the difficult thing about this computer here is that this Userport has a bug when you try to transfer binary files over this port. So this is the Raspberry Pi, and this here are the GPIO pins. These are pins that you can use for several purposes, and you can program the pins over Python. This is the script, and I hooked it up to a level shifter because these pins here run on 3.3 volts and the Commodore Plus 4 needs 5 volts. So I bought this level shifter here, which translates the 3.3 volts to the 5 volts. Normally this is not necessary, but I had several problems along the way, so I thought that this is the problem because it didn't work. As I said, it took me a few weeks to get this working. So I left it because the advantage is that the circuits are separated on this board. So if you move this, the cables here are not very long, so if you move the Raspberry Pi, you're not in danger to rip off all the connections here. In order to get this working is, first of all, find something to fix the bug of the Plus 4 regarding the Userport, and I found something on the forums on the Plus 4 world, and there is a fix for it which is done several years ago, and you have to load this fix which fixes the 0-byte bug. So the thing is, as far as I understood it, and that was the problem that I had, if you send 0 bytes, then the reading doesn't work. This causes several problems. I can show you the effect if you want. So let's load the program. So I run it. So this is the list here. So this is very short. Basically, this is the configuration of the colors, here graphic mode. Then I open the serial port. The first problem that I had was that I didn't know that I have to configure the serial port. So I had only this open 2.2,2,0. But over this parameters here you can configure the speed of the port. The Commodore Plus 4 supports speeds up to 1900-200 baud, and that's very fast. That's on par with the Amiga or the Atari ST. So this was the first problem that I had to solve, to find out, because I didn't read the documentary first. So this is the address for the graphic screen in graphic mode. This is the start address. We subtract the 2 because within the file that we load, this is an image file, the first 2 bytes are the start address where the file is loaded. So you have to subtract this from the start address here. Then peak 2003 means how many bytes are on the serial queue. So if we don't have any bytes which come from the Raspberry Pi, then we do nothing. Then we go here to the line 5. Then line 6 is so we get the byte from the buffer and poke it into the memory screen. So, and if we reach the end of the memory screen, then we leave the program. That's all. So easy, in theory. So I didn't load the bug fix for the Userport, and now I will run the Python script which loads a file here. It's on basically a screen dump with a TIE fighter. This is the data 200, and sends it over to the Commodore Plus 4. So you can see this is the effect. These are the 0 bytes, and they are interpreted in a false way. They are not interpreted as 0, and this causes the effect. You can see here how the TIE fighter appears, but this is not the right way to do it. So I will stop this here. I will stop the script here on the Raspberry Pi, and we will start again. So we load the bug fix. So this is the bug fix. So I will leave a link where you can find it. So we run this, and basically it fixes the ROM for the RS-232 port here, serial protocol. Now run it, and now the thing is fixed. So we load the program again. So we run it, and now we run the Python script which sends the data to the Commodore Plus 4. And well, I personally hoped that I would achieve these 1900-200 boards, but there is a sweet spot here. You have to build in a wait function, a sleep function. So when you send the byte here, as you can see, we have to wait until the Commodore Plus 4 processes the transfer. I'm very happy that I got it working at all. And as you can see, the TIE fighter is here transferred at a very, very low speed. I can show this here to you. You can take a look at the Python script if you want. So I hope you can see this. So we have the maximum baud rate here, 1900-200, but this hasn't any effect on the speed. And then we transfer 8 bits and no parity and 1 stop bit. We put the file name together, and then we open the file here with this function here. Here with open file name, RB means in raw bytes. So, and then we go through the file byte per byte. So we read the file, 1 byte here. And then we write the byte over the serial port. And by writing this, transfers the byte here over these cables to the Userport. So, and this is the crucial part here, the sleep function here. We have to wait 0.5 seconds and allow the plus 4 time to process the whole thing here. And as you can see, this is very, very slow. Unfortunately. So I guess first it's basic, of course. That's what makes it slow. And second, I think this configuration here with the Raspberry Pi and the breadboard This might end the level shifter. Maybe if I take off the level shifter, I can show it. If I take off this level shifter, which is not, in theory, not necessary, but I haven't tried it out yet. So maybe this is the reason why the transfer rates are so slow. Well, this is the fastest that I could get out from this setup here. So friends, that's it for today. I hope you enjoyed the video as much as I enjoyed making it. If you want, I can make another video about the RS-232 protocol and all the challenges that I faced making this work here. I had many problems getting this working. When you have never done something like this before, it's of course a long journey. Never give up, never give up. If you are stuck, sleep a night over it, and the next day you can see some other ways to do it. So friends, thank you very much for watching. I wish you a nice day or evening, depending on where you are, and see you hopefully in the next one. Bye bye.